Hi, welcome back to our simulation session. This is the final project. I will show you how this fish counter works. We have several major parts of this circuit. The first is infrared detection circuit. Second is a logic processing unit. We have Schmidt trigger, counter, and segment drive for the final display. At the bottom, from the left, is the power supply unit. We have AC in and DC out. On the right, it is a buzzer module. When the output from the counter is 1001, there will be a trigger signal to make this buzzer sound. Let's look at the infrared detection circuit. We click the Place menu and choose Component. And it comes from the group of Basic, Rated Virtual category. And we scroll down and to find Photo Diode Rated. This is the IR sender. And in the meanwhile, the photo transistor rated is the receiver. From the IR sender part, I introduced a 5 volts battery and a protection resistor to form a full loop. And this switch, there is a shortcut of space. We could change from open and close state. And on the receiver side, there's nothing too much to be changed, but introduce an LED 4 to indicate there's an incoming impulse. The cable in the middle of LED 4 and U7 directly goes to threshold and trigger pin to form a Schmidt trigger. Now I drag a virtual oscilloscope to connect it with this cable and run the simulation to check if there is pulse coming. Now we double click the oscilloscope and press S1. There's an obvious pulses coming from the middle cable, and it will generate the source for the Schmidt trigger input. For the logic processing unit, the Schmidt trigger output will directly goes into CD4518 as an incoming impulse. CD4518 receive the incoming impulse from CP and generate the BCD output code to U3. And finally, the decoder CD4511BD will drive the segment display through this protection resistance pack. Power supply is an AC to DC converter with the 9 volts peak to peak 50 Hz signal input into the Wins bridge, and after the regulator, it generates the voltage nearly 5 volts. You could adjust the output DC voltage by changing the input or change the regulator part. The final part is the control module. So for Q1 and Q2, when the counter output 1001, double high voltage will make the two transistors conduct, and the voltage drive the relay to attract the current through this buzzer, and the buzzer will be buzzing as an alarm. Now let's link all the major parts together and run the simulation to test if the infrared light could detect moving objects by pressing the S1 switch. Before we press the run button, I have a setting to tell you if there are some errors signs appear on your screen. Now let's go to Simulate and jump to Analysis and Simulation. For the first item, we just choose the tab Analysis option and press the Custom button. Here there's a default value, but right now I have changed to a more tolerable settings. eptol, vimtol, and ritol should be changed to a large number. And we clicked transit. And for integration method, we choose GIR instead of tripazodine. First of all, let's close key B J2 to reset all the display. Now let's control S1 with the space key to see whether the number has been counted through the movement of objects. And when it counts to 9, I think the buzzer will be buzzering. Yes, it did, which means our controlling scheme is working. Now, when the counter comes to 9, it will be reset automatically to 0. The whole fish counter project is a relatively complicated problem. We could separate it into different major parts and compose them together to realize a function. Now you have learned everything and try to apply it into your real lab and make a PCB to test it. Thanks for watching. See you next time.